Hi, my name is Stephen McGee and I'm the author of Toxic Health. We're here today to look into dirty electricity, or as it's known in the electrical industry as harmonics. And we have a circuit behind the oscilloscope, and you can see those light bulbs in the background. Half of them are on a switch and half of them are on lamp dimmers. And we're going to demonstrate the difference between the two. And on the oscilloscope you can see that we have a voltage waveform in yellow, and we have in red the current waveform. And currently we have no current because the lamp bulbs are switched off. So I'm going to switch on the first three light bulbs, and we can see that we now have current, and the current is following the voltage waveform, so they're in line, and that's what you expect on a resistive load. So if I switch that off, we can switch on a lamp dimmer. And we can see it's quite different. So there you have it. Lamp dimmers actually function by chopping up the current waveform. And when you do that, you get a noise on the voltage waveform and also on the current waveform in the form of a little spike. And that creates really bad harmonics on the system. And you get a lot of emissions coming off the system in the form of electromagnetic radiation and interference. So let's turn on our second lamp dimmer and see what happens. So you can see with two lamp dimmers on, we have a very distorted current waveform, and it's stepped. So it's partially digital with that digital switching of the light halfway through the waveform. And that creates a lot of really bad noise on the system. And it gets even worse when you put the third light bulb in. So that's what it looks like when you have three light bulbs all being controlled by different controllers and switching at different points on the current spectrum. So we can see that during the current flow we have these interruptions where the lights switch off, and it's very much a stepped waveform. And you get some very interesting waveforms around lamp dimmers for that reason. And I'm going to show you the frequency. I'm going to put on what's known as a fast Fourier transform. And right now what we're looking at in the horizontal direction is 500 Hertz per division. And you can see that in the low end of the frequency spectrum it's very noisy and it tails off as we go into the higher end. I'm going to drop down to 50 Hertz per division. And we can see the fundamental 60 Hertz waveform right there. And then we see the harmonics tailing off. So let's go and see what it looks like up at 10 kilohertz per division. So that's what 10 kilohertz per division in the horizontal direction looks like. So you can see it's very noisy, and all that's coming from the lamp dimmers and the light bulbs that they're switching. And this is what 100 kilohertz per division looks like. So it's very, very noisy, and that noise will show up as radio waves and an extended electrical field and an extended magnetic field, and there'll be some other fields around this equipment too. So that's what harmonics is. It's something you need to be careful of. Because of these effects, I don't recommend that you have lamp dimmers in your home, and it's something to be aware of. If you have noisy electricity that's giving off electromagnetic interference, then it's probably in your interest to contact an electrical engineer who is familiar with power quality, and have him come into your home and inspect it and inspect the voltage and current waveforms, and you may find some very interesting stuff going on your home electrical system that you may want to get rid of. I hope you enjoyed this presentation, and I wish you the very best of health. Thank you.